Hello and welcome to a new video. This is for Zeta Math UC and we're on lesson 27, and this is going to start a few lessons where we kind of talk about geometry. So there's going to be a lot of vocabulary, and it's going to feel a little bit different, I think, than a lot of our lessons have, because there's not like a lot of calculating to do. By calculating, I mean we're not like adding, subtracting, multiplying, and dividing, at least not in this lesson. So first off, what is geometry? If you look at the origins of the word, you get basically two parts to it. The geo part means earth, and the part where we get the metry comes from a word that means measure. So it kind of literally meant the measure of the earth, and that in a lot of ways is still what it means, but we also use it to kind of describe a whole part of mathematics or a branch of mathematics that deals with not just measurement, but also like properties and relationships of points, lines, angles, shapes, and solids. So if you think of shapes like squares and triangles and circles, geometry deals with those things. If you think about like cylinders or pyramids or things like that, geometry deals with those. But also if we just think about like lines and points and angles, if you know what those are, that is also something we do with geometry. So in this lesson, we're going to be focused on four things: points, lines, rays, and line segments. So we're going to go through and list some things about each of these. And the way that the workbook lesson goes on this is that it's a lot of vocabulary, a little bit of matching up of some things. And so what we're going to do is we're going to list some things that are true about each of these words to help you be able to fill in that vocabulary. For instance, whenever we have a point, we are going to draw a picture of what a point looks like. A point is just a dot. And in math, we like to name things that we draw. So this dot we can name with any letter we want. We a lot of times label it with capital letters, although I don't know that it really matters. So I'm going to label this point P, because I'm super original, like all math people are. So this is point P. If we had multiple points, we'd name them different letters, and that way, if we wanted to talk about the same point, we would just be like, you're talking about point P, I'm talking about point P, and we'd know we were talking about the same thing. Some things to know about point is that a point is something that has no length or width. Because it's more like it's almost more like it's just talking about a location and not actually a space. We're not talking about the space where point P is, we're talking about the location that point P is. It's actually also kind of the smallest unit of measurement that we can come up with. The smallest unit of measurement or something like that. As I go through this, I'm trying to remember kind of what some of the things they ask us in the workbook are. So the idea here is that if we have a point, we're kind of talking about like a location. And so if something's at that location, like a literal thing, like a person or a box or a car, like that object does have length or width. But when we're talking about points, we're just talking about the very smallest possible, so small that you wouldn't actually be able to see it, like location that there could be. And so even the fact that we draw a dot actually makes it look bigger than what that location actually is. We can think about points when we're thinking about like GPS on phones or in your car, and when you're going someplace, you're using the directions, your phone is basically a point, a location that's being tracked, and then the place you're going to is a point that's being tracked, and those points can move, but it's a location that's happening. So that's point P. A line, we draw. You probably know what a line is, but in math and geometry and algebra, when we're talking about a line, we mean something that goes on forever in each direction. So goes forever in both directions. And so we show that by putting arrows on either side. If you don't have arrows drawn on the end, someone else isn't going to know that what you mean is a line, that those arrows are important. We typically will put at least 2 points on a line. You can put more, but we need at least 2 if we want to be able to name this line. So the way we would, if we're like writing down stuff about this line and we don't want to write out the word line because we're lazy, because we're mathematicians, we would write the 2 letters that for the points that are on this line, A, B, and then we actually just make like a miniature version of our line up above. It's a really weird way actually of naming things, and it just goes to show how, I don't know, unoriginal mathematicians are, or how much they just didn't want to have to like be creative or think about this, which actually is a benefit to us, because the more creative we were when naming these things, the more likely it would be that we'd have to actually like memorize it. All we need to do here is be like, okay, it's line AB, so I'm going to put a line over AB. You actually can name it BA as well. These are both talking about the same line. It doesn't actually matter which order we put it in, since it goes on forever in both directions. A thing about lines is that we could say that it doesn't have a width, but it has an infinite length. So the word infinity is under line segment here. So that's a word we're going to define later as well. But infinity or infinite is this idea of something really, really big or something going on forever. So what matters here for this line is we don't care how wide it is. Like I can adjust the thickness of my pen and make the line look wider, but a line actually, we're not concerned about how wide it might be. We're just looking at, okay, it goes on forever in both directions. So we couldn't actually say what the length of it is, because the length of it is infinity. It's like really big. I feel like there was something else. Oh, you can think of a line as something that's made up of points that basically, this going back to our GPS example, right? So you've got your point for where you are, you've got the point for where you're headed, and if we draw a straight line in between it, which it's not likely that that's the path it's going to take us, right? Because roads. But if we could draw a straight line between them, like we could think of each little teeny tiny location in between as a little point. So our line is made up of little points along the way. So a ray, you could relate the word ray to other ways that we use the word ray besides the way we use it in math. So I think of sun rays, which start at the sun and then go until something stops it. You could think of like a ray gun of some sort, like a freeze ray gun or some other ray gun that starts at some point and keeps going again until it runs into something. So a ray is different from a line in that it starts at an end point or an origin, and then it goes on forever in one direction. And now that there's a band called One Direction, this is probably going to make you, well, about half of you want to start singing a One Direction song. I'm not going to sing it because then I might get a copyright thing on my video, and I don't want that. But yeah, it starts and then it goes forever in one direction. We also name these with 2 letters, so I'll use C and D. This time it matters what order we put it in, because we want to, we're going to make a miniature ray up above it. And so we want to put the starting point first, and then the other point, which is what it's going through, as second. So we could name this ray CD. And I don't need to actually really like make this look like an end point. And man, that arrow doesn't really look great, but we're just making a miniature ray up above CD so that somebody looking at this would be like, oh, you're talking about a ray CD, because look, that looks like a ray. So this one goes forever in one direction. It also has no width, just infinite lengths. It's also made up of points. And this is where we have this weird idea of infinity, because a line is infinite, but also a ray is infinite. But because a ray starts someplace and a line doesn't, the infinite that a line is automatically bigger than the infinite that a ray is. And if that doesn't make sense to you, then maybe just ignore it for now, because this is a kind of a big concept with infinity that will be, really interesting later on, hopefully. Okay, let's look at line segment. So a line segment is a segment, which means a part of a line. And so instead of having arrows, we're actually going to have two endpoints, and then our line is going to go between. And so let's see, I'm going to use E and F. So this line segment just goes from E to F. It doesn't keep going. And so when we name it, we put E and F, and we put a little line over it without arrows to show it's a segment, not a line. This case, we can write it either direction, and that's fine. This time it doesn't go forever in one direction, though. The line segments have a measurable length, meaning that if you have a ruler, you can actually sit here and measure how long a line segment is, assuming you have a long enough ruler or, that sort of thing. It's also made up of points. It also doesn't have width, but it does have a length. So infinity, there's a symbol for, which looks like an 8 that's on its side. And if you make it all the way to Algebra 2 and beyond, which most of you will, infinity symbols are something that you'll end up drawing quite a bit at that point. So at first, they're kind of weird and awkward to draw, but as you practice, they'll get better. So if right now you end up like turning your paper sideways, drawing an 8, and then turning it back, that's fine. But at some point, you'll probably start having to draw enough of them that they'll start to look a little better as you go. I've had lots of practice personally. So infinity is this idea that we have a really, really, really big number happening. A number so big that we actually really can't even comprehend it. So it's like saying the biggest thing that it could ever be, or something like that. So when we talk about something being infinite, we're talking about something that is so big that that we can't even really like define it. We can't call it like 1,000 because it's bigger than 1,000. We can't even call it 1,000,000. It's bigger than 1,000,000. It's so big we can't even really fathom or imagine how big it is. And so when we talk about lines going on forever and being infinite, that's what we mean, is that they go on forever, which is not actually something that we as human beings can really comprehend in some ways. So that's the symbol for infinity. And I think that mainly is in kind of a matching situation. So the other thing we're going to do, besides basically some vocabulary and matching, is we're going to be given some figures and be asked to name those figures with letters and symbols. So you're basically being asked to remember, okay, if it's a ray, I put a little ray over it. If it's a line segment, I put a little line segment over it. If it's a line, I put a little line over it. And then I use the letters they gave me. The only one that the order matters on is a ray, which is the first one, that it has to be A first and then B, because for a ray, I mean, I guess you could do it the other way if you made your ray face the other direction. That basically we're saying that the letter that's next to our like starting point is our starting point on this ray. So this would be AB with a ray pointing to the right. This next one is a line. And so we could either write HL with a line over it, make sure you put the arrows, or we could write LH with an set of arrows over it, or a line with arrows over it. DF is a line segment, so we'd write DF and then just draw a line segment over it. So a line that does not have arrows. Hopefully this lesson goes pretty well. It's definitely one that I think if you try to sit down and do all of the pages at the same time, it's going to seem really, really repetitive and boring, and you're not actually going to get the most out of it. So it'd be better to split it up over a few days, because it kind of asks you the same questions, or pretty close to the same questions, over and over again. So the better strategy would be to like sit down and do maybe have these notes or this video handy to help you fill it in. And then as you, the next day and the next day and the next day, go through the other pages, you try to use your notes or other resources less and less, by ending up memorizing these things. Because what we want to do with math, when at all possible, is we want to take things like this that maybe at first we have to memorize, and we want to make them be just a part of how the world works for us. So it's really not hard to memorize things about rays and lines and line segments if we're just like, oh, that's how it is. That's how we name these, and this is a thing that happens. We did that, initially whenever we learned like 2 + 2 is 4. It became something that just made sense to us, and so most of the time we don't really have to think much about 2 + 2 is 4. But even if we do, we understand how it works, right? So that even if you have to sit there like my 3-year-old and go, well, actually, yeah, my 3-year-old and go, okay, 2 + 2, and then count them and you get 4. Even if you have to do that, you've still accepted into your brain how addition works, right? So you're not really actually having to think from scratch about that situation. This is a random tangent, sorry. Thanks for watching. Please give me a thumbs up on the video to show that you liked it, and subscribe if you haven't already, and I'll see you in the next video. Thanks.